Hey, hello physical science, this is Mr. B. We're continuing on today with section 2, and the title of this section is Newton's first and second laws of motion. So you guys, I'm almost positive you've probably heard of Newton's first and second laws of motion. I don't know if you could recite them off the top of your head, but for the most part I know you are at least familiar with what is stated in them. And today we're just going to focus on the first law of motion and the work of a couple other scientists that helped lead Newton to his conclusions. So our first one talks about how Galileo actually played a big role in helping develop Newton's laws of motion. So his work helped correct misconceptions about force and motion that had been widely accepted since Aristotle's time. So Aristotle was one of our first scientists that tried to describe motion, and if you remember, he also dealt with states of matter and things like that. So he was a big thinker of his time, and he kind of had some input on how things moved as well. So it took about 2,000 years to develop modern understanding of the relationships between force and motion, because again, Aristotle was back in the BC time, so people accepted what he said for a very long time, kind of without question. So it took about 2,000 years before Galileo came along to correct the misconceptions that had originally been made by Aristotle. And those original, inconsistencies that Aristotle came up with, again, they weren't like he was just making stuff up. He did make scientific discoveries through careful observation and logical reasoning. So the base of what he was doing was correct, but again, he just made incorrect assumptions. So his first one is that he incorrectly proposed that force is required to keep an object moving at a constant speed. So he determined that once an object started moving, that he thought that a constant force had to be applied on it all the time to keep it moving at a constant speed. And honestly, that's not too big of a misconception to me. That almost kind of seems like common sense. Like, yeah, you would think that in order for something to keep moving, a force would have to constantly be acting upon it. But that was actually incorrect. So when Galileo came along, he studied how gravity can produce a constant acceleration, again of that 9.8 meters per second squared. So what he did was he rolled a ball, or multiple balls, down wooden ramps, and he concluded that moving objects not subjected to friction or any other force would continue to move indefinitely. So remember, we did the example of friction in class with sliding the things across the floor. So friction is what caused those objects to slow down. So Galileo concluded that if there were no friction, those objects would keep moving forever. And again, I think that's what I said. The chair would just kind of keep sliding around back and forth within the room until infinity, basically, if there was no friction. So Galileo was the first one to confirm that. He said that, again, a moving object not subjected to any friction or any other force would continue to move indefinitely. So Newton took that work and he ran with it. He built on the work of scientists, Galileo being one of them, and he first defined mass and force, and he then introduced his laws of motion. And the name of his book, just a little fun fact here, maybe jot that down for your quiz. And sorry, Monty just barked there in the background. The first book was entitled Principia, so that was the name of the book where Newton published all of his works. And one of the things that he published was his first law of motion. So according to Newton's first law of motion, so I would definitely write this down, the state of motion of an object does not change as long as the net force acting on the object is zero. So you've probably heard this worded a little bit differently, and we're going to get to that in a second, but this is the basis, or this is what Newton's first law states. The state of motion of an object does not change as long as the net force acting on the object is zero. So what that means is, it says unless an unbalanced force acts on an object at rest, it will remain at rest. So I'm pretty sure you've probably heard this before. An object at rest remains at rest. And then for the second part of that, an object in motion remains in motion. So unless an unbalanced force acts on an object at rest, that object will remain at rest. Unless an unbalanced force acts on an object in motion, that object is going to remain in motion with the same speed and the same direction. So that's probably the wording you've heard for Newton's first law. Again, an object in motion stays in motion. An object in rest stays at rest unless an unbalanced force is going to act upon it. And A big term that goes along with Newton's first law is inertia. So it's the tendency of an object to resist a change in its motion. So objects don't want to stop moving if they're already moving, and objects really don't want to continue to move once they let me rephrase that. If an object in motion, again, it wants to stay in motion. If an object is rest, it wants to stay at rest. So it wants to resist any change in its motion. So a good kind of example of this is a crash test dummy, and it will show that its forward motion, it continues its forward motion as the car slows to a stop. So we can see this car, obviously, again in this picture it looks like it's at a standstill, but this car is moving forward, getting ready to be crashed into this little wall right here as part of a crash test dummy. So that's the first step. It has yet to make contact. When it makes contact, you can see the crash test dummy moves forward because the car is moving forward. The crash test dummy does not want to change its motion. It has inertia. It's resisting a change in motion. And then we can see now the crash test dummy, the car is still moving forward, so the crash test dummy goes even farther forward. And then finally, once the car slows and stops, the crash test dummy returns to its original position. So that is Newton's first law. Again, an object in motion tends to stay in motion, an object at rest tends to stay at rest, and unless they are acted upon by an unbalanced force. And then that tendency to resist the change in motion is known as inertia. So those are the biggest keys here to Newton's first law. So that's it for this video. Let me know if you have any questions.